how the industry started, and where we use different heat pump applications. So for any of the very experienced people here, this is just an overview, okay? So I suppose, as Stephen has said, I've been in the industry for a long time, and I first, I suppose, got involved in air-to-water heat pumps around 2007 or 2008 when they were a new technology in Ireland. Prior to that, geothermal heat pumps would have been the heat pump of choice, and there was great stability with them because you were using a stable ground temperature. Um, Anyone that was probably involved in the industry back in those early days knew that there was a lot of fear around air-to-water heat pumps because it wasn't sort of, it was a new technology to the industry. We didn't have historical data to say how they would perform in our climate here in Ireland. It wasn't regulated or anything like that, so we were kind of taking a punt on this technology. So I'm sure anyone that was involved at the time would agree that we all sold very, very large capacity heat pumps to everyone we could, because we did not know for definite if these were going to be successful or not. So there was a lot of kind of 14 and 16 kilowatt heat pumps being installed back then, and at the moment, with the developments in building regulations, that is completely turned on its head, and it's mostly smaller capacity units that we install. So the developments, I suppose, with the building regulations in 2009 and compliance requirements mean that now houses are so well insulated, they're airtight, and so much smaller capacity units, small, neat, single fan units are what's been used for the most part. So for anybody that's new to the industry or considering getting involved in heat pumps, it's definitely a good time to do it. Heat pumps will be a part of our lives for forevermore, because they're a requirement for the new build sector to meet compliance for renewable energy contribution. And also, in line with that, the government action plan requires that 400,000 heat pumps are installed in retrofit situations. So existing houses with oil and gas boilers have to start replacing those systems with, heat pump technology generally, to electrify heat demand and to reduce carbon emissions. So in total, the Climate Action Plan requires 600,000 heat pumps to be installed by 2030. And to put that in context, the Heat Pump Association publishes figures every year as to the number of heat pumps that are sold. And in 2021, approximately 20,000 heat pumps were sold. So we're a long way off meeting a target of 600,000 heat pumps, and we have a lot of work to do. So I'm just going to hopefully get my presentation to move here. 1 second. Okay, so the technology that I'm going to talk about today is air-to-water heat pumps, air-to-air systems, which ordinarily would have been installed more so in retail, offices and stuff like that, but starting to come into the residential sector now, and also exhaust air heat pump systems as well. So within the air-to-water heat pump technology, there are many different types of heat pumps. So the first one here on the top right is a refrigerant split, and that means you have a refrigerant connection going between the indoor and the outdoor unit. In order to install a refrigerant split, you need an F-gas qualified engineer on site to make the connections between the indoor and the outdoor unit. And these units generally come pre-charged for about 10 meters, but you can go up to a distance of 30 meters between the indoor and the outdoor unit. So when additional gas has to be added to the system, that's also a job for the F-gas engineer. With refrigerant splits, you have no concerns about freezing, and you have no concerns about heat loss in the pipework between the indoor and the outdoor unit. The next one then is a hydro split. The hydro split, similar to the refrigerant split, but it's a water connection between the indoor and the outdoor unit. And when you have a water connection, you generally want to keep your units a lot closer together. You're reducing heat loss, and your pipework needs to be very well insulated to make sure that you don't have freezing in very low temperatures. The next one then is the monoblock. So, okay, that's gone on over there to a hybrid unit, sorry. The hybrid unit is a combination of a gas boiler and a heat pump. It's not a very popular one here in Ireland, but it is good for the retrofit market as kind of a stepping stone product between going from a gas boiler directly to a heat pump. You can put in a hybrid system the heat pump will do about 25% of the contribution, and it just means it reduces your energy bill and increases your efficiency. Not a huge seller here in Ireland, but it is a big seller in the UK and in Europe. Another unit then that we have for retrofit would be a high temperature system. So the high temperature is a direct replacement for oil and gas boilers in that it will give you up to 70 degrees of a flow temperature. It's a hydro split, so it's a water connection between the indoor and the outdoor unit. They work really efficiently at very low outdoor temperatures because they're really designed for the Nordic regions where they have prolonged minus temperatures. Not something that we really get here in Ireland. So we haven't really found an area of the market that it really suits. But going back to the monoblock would be one of the most popular models available on the market. So for anybody coming into heat pumps for the first time, this is a really good option. There's no F-gas requirement, so all of the components are built into the outdoor unit. You'll notice that the outdoor unit is usually longer than a split unit because all of your hydraulic and electrical components are built into the outdoor unit. And from that, you just take your connection into the house, into a 3-port valve to divert between heating and hot water, and then onto your cylinder. So it's a very nice kind of a starter product for anybody getting into air to water heat pumps. So just to give you the difference between splits and monoblocks. So generally, refrigerant splits would be one of the most common types of air to water heat pumps available on the market. And with the refrigerant split, obviously you've got your refrigerant line going between your indoor and your outdoor unit. And the big thing, I suppose the difference between splits, hydro splits and monoblocks is the location of the heat exchanger. So the heat exchanger here is represented in the little yellow triangle, and it's a part of the refrigerant cycle. So wherever the refrigerant cycle is, the heat exchanger will be. So a refrigerant split, you have your refrigerant line going between the indoor and the outdoor. So it's located in the indoor unit. In the hydro split and the monoblock, the refrigerant cycle is contained within the outdoor unit, and so the heat exchanger is in the outdoor unit. So most people would be familiar with refrigerant splits and monoblocks. The hydro split is kind of an in-between product, which allows you to have the nice integrated indoor unit, but to have a water connection between the indoor and the outdoor. So it kind of fits in there into a nice, easy to use, easy to install category. Generally used in kind of larger one-off properties. Also, that would be a medium temperature heat pump, so it goes up to 60 degrees in domestic in heating. So they're a very good option for retrofit solutions. So that, I hope, just kind of gives you the difference between the 3 types of systems, because if you're not used to the technology, I suppose it can be a bit confusing. Now my slides are very slow to move. One sec. Okay. Sorry now. Technology letting me down. Okay, so the next type of system is an air-to-air system. So ordinarily, this would have been used in Ireland in retail. They're used to cool comms rooms. They're used in offices for heating and cooling. A fantastic system for any type of a building that has intermittent use. So if it's like, believe it or not, funeral homes are actually a type of building that use this technology because they're intermittent use. You don't necessarily know when the building will require heat. So for instant heat, these are fantastic. But recently, in the last probably 2 years, these have started to become quite popular for residential solutions, and specifically in retrofit scenarios where there's existing storage heaters. So in small local authority and social housing units where there's storage heating and it's going to be too disruptive to dig up floors and put in radiators and an air to water heat pump, this is a really good solution because the pipes can be run at high level, and we use these high wall units that you would see in, say, an apartment in Spain when you go on your holidays for air conditioning. So with this system, this is called a multi-split. You can have up to 5 indoor units connected to one outdoor unit. All of the pipework run at high level, high walls up on the wall, and very little disruption inside in the house in relation to digging or, you know, removing floors and stuff like that. So an add-on to this system is a domestic hot water cylinder. So up until recently, that air-to-air system could only offer heating or cooling, heating and cooling, we'll say, but you also had to get a separate solution for your domestic hot water. So just this year, Daikin brought out what we call the MultiPlus. And this is a domestic hot water cylinder which is connected to the outdoor unit. So now you have an air-to-air system that gives a complete solution for heating, cooling, and hot water. And it's getting the full renewable contribution for the domestic hot water as well as the heating and cooling. So this is a really, really nice solution. Where up to now we've been using this in retrofit scenarios, this will be used in new build as well, where there's a possibility to fit an outdoor unit in apartments or holiday homes or any type of building with intermittent use. This is a great solution. So finally then, exhaust air heat pumps. I'm sure most of you are probably familiar with these. They have become very, very popular in Ireland in the last couple of years for use in apartments, and their biggest benefit is that they don't have an outdoor unit. And in small spaces, they work very, very well where there's a low heat demand. So the way they work is, instead of being connected to an outdoor unit, they extract the warm air from bathrooms, kitchens, utility rooms, and that's used as the renewable source to provide heating and domestic hot water for the apartment or the building. So passive houses would use this type of technology. They have done for years, but in more recent years, these have become much more popular in apartment buildings where there isn't a balcony or there isn't outdoor space or space on the roof to fit outdoor units. So again, very interesting technology. There's varying quality in different types of units out there. This is an EB unit. It will be a very high-end unit that has been used for years in passive houses. And as I said, I suppose they're more commonly used now in apartments. So then the applications for the different technology. So in new build applications, we would generally use small capacity monoblocks and refrigerant splits. In apartments, we also use this technology as well, but I suppose more commonly exhaust air being used now. In larger capacity, one-off self-built houses, we'll say, the most common technology used there would be larger monoblocks, larger refrigerant splits, and also the hydro split. For retrofit, the monoblock will be really useful because you don't have any indoor unit with it. So there's less disruption in using a monoblock. The hydro splits, as I said earlier, they're a medium temperature, so they will run up to 60 degrees in heating. And the high temperature units, where you have maybe like an older period house where, you know, there might be very nice old cast iron radiators or something like that, where the radiators can't be changed and therefore you want to keep the system as a high temperature system. That's where it works really, really well. In apartment retrofits with existing storage heaters, as I was just saying, the air to air is a really good solution. The MultiPlus, so air to air with the domestic hot water cylinder, and also exhaust air units. And the exhaust air really, I suppose, where they'll be used is apartments and passive houses. So just to give you an idea of how heat pumps fit into existing properties with existing heating systems, they work with both radiators and underfloor heating. So if you have underfloor heating in a building, it's really, really easy to retrofit a heat pump. It works really well with underfloor heating because it's already a low temperature heating system. So there isn't a lot of changes that need to be made in the system. If there's radiators, some radiators might need to be changed. You can use aluminium rads and steel rads. There is a requirement under the SCAI grant funding that a heat loss calculation needs to be carried out to make sure that the existing radiator will still be able to heat that room if you use a lower flow temperature from the heat pump. So ordinarily you might be heating that radiator at 60 degrees. Now you want to run your heat pump at 45 degrees. Will the existing radiator be big enough, or will it need to be replaced with a larger radiator in order to meet the desired room temperature? So that's a calculation that needs to be carried out every time. Existing systems should be power flushed. So with radiators that have been installed for the last 10 or 15 years, there's usually a build-up of sludge or debris or whatever in the system. So if the radiator is only operating at, say, 70%, when it's been heated at 60 degrees, now you want to heat it at 45 degrees. You want to make sure you're getting 100% out of the radiator as opposed to 70%. So flushing the system is required every time. And then in terms of how we operate heat pumps, we would recommend that they're left to maintain a set point room temperature rather than run on a schedule like the way we run our oil and gas boilers. So rather than getting up in the morning and turning it on for an hour and leaving it off all day while you're at work and coming home and turning it on and turning it off, we say run it on a set point, maintain the desired room temperature, and you will have a very comfortable, while you might be running it at a lower background temperature, you'll have a very, very comfortable ambient temperature all day long in your house. So the comfort levels are generally improved greatly when you use heat pumps in this way. The domestic hot water is fully managed by the heat pump controls, and it has a built-in disinfection function for Legionella. So it's a preset factory setting. Once a week, it'll bring the tank above 60 degrees and hold it there for 10 minutes. So there's no external controls required for domestic hot water production with heat pumps. And in some cases, in retrofit, I suppose over the years, people, when they were building a new house, they were considering future proofing at the time, even if they didn't put in a heat pump initially. A lot of the time, people did put in a cylinder that would be suitable if they put in a heat pump down the line. So sometimes the cylinders can be used. There is a specific requirement for the coil size of the heat pump. It needs to be larger than what it would be to be heated from an oil or gas boiler. So that just needs to be checked. But I suppose in cases where you can use the existing cylinder, it reduces the disruption in the house in terms of rerouting pipework or changing pipework or whatever. So while it is daunting, the thoughts of having to retrofit all of these heat pumps, it is doable, and we will get there, but with a lot of hard work, I think. So just in terms of the efficiency for anyone that's kind of new to looking at how this technology works, it's a renewable energy source. It takes its energy from the air, and the efficiency that we talk about with heat pumps is the term that we use is COP, coefficient of performance. So that relates to the amount of energy that we use to run the heat pump versus the amount of energy that we get from the heat pump. So this diagram just represents that for 1 unit of electricity, we get 3 units of energy free from the air, and that gives us a total of 4 units of energy for heating our house. So that's basically a COP of 4. And to give you just a real life example, this is my own heat pump that I have in my own house here. And it shows you the energy used and the energy produced. So you can see this heat pump has been in for about a year. It used 3,806 kilowatt hours of energy, and it produced 15,897 kilowatt hours. So this has given me a coefficient of performance of 4.17, and that's across both heating and hot water. So I'm pretty happy with that. So that's basically it. That's the overview. I hope it's been useful, and if you have any questions, please feel free to go ahead and ask.
That's perfect, April. Thank you very much for that.
I'll just stop sharing here.
That's okay.
Okay.
That's perfect. We have one question in the chat, all right, from Benny McDonough asking, is there a system where a heat pump can be added to an existing fossil fuel system and supply 80% of the heating and allow the oil to supply 20% for the building as is retrofitted over time? So that's the kind of first question of a loaded question. So.
Yes, well, absolutely, it's possible. it's possible, and it can be set up in a way that the heat pump is the main heat source, and at a certain condition, it will bring in the boiler as a backup. That might be at a certain outdoor temperature, or when there's a certain capacity required in the system. What I would say is that would not be funded under SCAI grant requirements. So while it's possible, and in sometimes in larger properties, that's something that you really do have to consider, because like the largest heat pump in the domestic range is usually around 14 or 16 kilowatt. So if you have a house that requires a capacity of say 20 kilowatt, you know, sometimes it makes more sense to keep that boiler there to do the percentage that's needed 5 times a year or whatever it is, you know what I mean? So the heat pump will still do the 80%. The boiler can come in to assist it when needed, but you won't get funding from SCAI. That's the only issue.
Perfect. Yeah, I think that's answered the question. I think it has. I'm seeing nods. Another question in chat: is there a requirement in the climate action plan for retrofitting of non-domestic to heat pumps?
Yes, there is. Now, is it there is a requirement for it. I suppose the 400,000 heat pumps is residential. That's a domestic requirement. But and to be honest with you, I'm not overly familiar with the non-domestic requirements, because I work specifically in residential heating systems. But certainly there is a huge demand for non-domestic upgrades in all sorts of applications. And I have come across it recently at different energy different seminars and different meetings that I've been at, where I was there in a residential capacity thinking everybody else was as well, but actually I was the only one there in a residential capacity and everybody else was there in a non-domestic. So there is huge demand. It certainly isn't my area of expertise, but we can see, like we would have a bigger chiller range, heat pump chillers that go from 16 kilowatt up to 60 kilowatt. And I think that there will be massive demand for those in the coming years, and across all sorts of different applications. So certainly non-domestic is going to be huge.
That's true. And just for those that are in the call, we're looking at providing a non-domestic webinar series sometime in the winter now. I think that's what we're looking at, December, and it'll be similar enough to how this is kind of played out, lunchtime talks, and we'll talk to various leading experts in the field, and we'll try and get that out to you as well. So just another question there for you, April, before we go. Yeah. I think we've a couple of them there.
Yeah.
It's like, in a retrofit scenario, where would you just want to replace the boiler? Does your house have to be airtight? So I'm guessing that's.
So basically, the SCAI's approach to the grant funding is a fabric first approach. So when you go to look for funding for an air to water heat pump, the first thing you have to do is get a technical assessor to come and do an assessment on the fabric of the building. They will give you a report with what the heat loss indicator of the house is. And there's a requirement for the heat loss indicator to be up to 2.3 in certain conditions. And that's the output from the report of the technical assessor. So he will, if you come in above 2 or 2.3, he will advise you what steps are required in order to get you back to the 2. So to give you an example, my own house here, this is a cottage, it's 120 years old. We renovated the whole thing. We dug out the floors, underfloor heating, heat pump, etc. Insulated, triple glazed windows, the whole lot. But we didn't insulate the walls. And when I did the technical assessment, our HLI, heat loss indicator, is 3.6. So I'm way outside of the requirements for a grant, but I have a heat pump and it works really, really well. So if you're going for a heat pump grant, you do have to do the assessment on the fabric. You'll get the report back, and that will guide you in what you need to do to upgrade the fabric. And what I would say to you is, for anybody thinking about putting in a heat pump in your house, whether you get a grant or not, you should be considering investing in the fabric of the building, because the less leaky that your house is, the less or the better insulated that it is, the more efficient it'll be and the more comfortable it will be. And that's ultimately what we're all aiming for. So definitely consider it, no matter what way you're going, whether you're going for the grant or not. It's good advice to get your insulation upgraded where possible, because obviously there's a lot of different types of construction, you know, like these are stone walls that we have, you know, it might be timber frame, it might be block. So depending on what the scenario is, do the best that you can. That would be my advice in upgrading it.
That's perfect, yeah. And last one now, and then I'll let you go.
Okay.
It's what floor area of sorry, that's another non-domestic question. There's a good question here. I know Mark in the chat has kind of answered it as well, but would it be correct to say that a retrofitting heat pump increases the overall electricity demand of a house? Again, I think this comes up a lot with even in our own studies as well. That
Yes.
people find that they're kind of scared to put in a heat pump because of electricity. They're worried that electricity will be more costly than traditional boiler.
Yeah, absolutely. And I understand that fear, but you know, there's another fear which is probably much greater than that, and it's the security of gas and oil in the future. And I think, like, I suppose the overall aim here is to electrify as much of the heat demand as we can, and then have renewable energy providing the electricity. So it's kind of a two-pronged approach. And yes, of course, you'll use more electricity if you have a heat pump, because your heat pump is run by electricity, but then you won't have an oil or a gas bill. So you're transferring from oil or gas onto electricity, but with a renewable technology that gives you a very, very high efficiency. So I understand the fear, of course I do, but at the same time, it's a step in the right direction, because oil, gas and electricity, let's face it, the price of everything is on the increase. But at least with electricity, we have a more secure, well, I would feel, I could be wrong obviously, but you have a secure source. And the developments that are at least expected for renewable energy, which is produced on the island, you know. And I think this is what's really important, and this is what people really need to be thinking about, is producing energy on the island, that we're actually have energy security here in Ireland, that we're not dependent on oil and gas coming from other countries when there's political instability and so on, as there is at the moment. So I think it's a really good time for people to actually be thinking about energy security. And you know, it's an unstable time out there, the way it is at the moment. But it will increase it will increase your electricity usage, but you won't have an oil or a gas bill. And one thing I suppose that is interesting to think about too is, if you have, say, LPG or you have oil, you have to have a big spend, like you buy your oil, you know, once or twice a year. It could be €1,000, it could be 500 or 600 euros, whatever it is. When you have a heat pump, you're paying as you go. So you pay your electricity bill monthly or bi-monthly. So it's all one bill. You can get a really good idea of what that bill is going to work out at monthly. You can budget it better, and you pay as you go, and you don't have to have that lump sum there ready for September when the heat's getting turned back on. So for me, I found that that's really helpful, actually.
That's perfect, yeah. Again, I like the idea of the self-sufficiency of Ireland, especially in energy supply as well. So that's it's really interesting. So thank you very much, April. We're just coming up on the time limit now, so there's more questions in the chat, and there's a lot
well, if you want to share, I can
too.
respond afterwards.
Exactly, yeah. I'll share the questions with you, and we'll try to get your answers out. And what we'll do is we'll also send a link to the recordings, where it'll be on the TUS RDI YouTube channel, and also we'll send out the PDF, the slides as well. So I'd like to thank April and everyone who joined, and hope you have a good day, and good luck.
Thank you very much.
Bye now.
Bye-bye.
Thank you.